Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young.
Chapter 4, Harmonic Constructions and the Fundamental Theorem of Projective Geometry. Section 37, Construction of Projectivities on One-Dimensional Forms. Theorem 23, a necessary and sufficient condition for the projectivity on a line MNAB projective with MNA'B', M not equal to N, is Q of MAB, NB'A'. Assumptions A, E, and P. Proof: let N be any line on N not passing through A. Figure 46. Let O1 be any point not on N or on MA, and let A1 and B1 be the intersections, respectively, of O1A and O1B with N. Let O2 be the intersection of A'A1 and B'B1. Then NAB is perspective through center O1 with NA1B1 and NA1B1 perspective through center O2 with NA'B'. By Theorem 17, the projectivity so determined on the line AM is the same as MNAB projective with MNA'B'. The only possible double points of the projectivity are N and the intersection of AN with O1, O2. Hence, O1, O2 passes through M, and Q of MAB, NB'A' is determined by the quadrangle O1, O2, A1, B1. Conversely, if Q of MAB, NB'A', we have a quadrangle O1, O2, A1, B1, and hence NAB is perspective through center O1 with NA1B1, which is perspective through center O2 with NA'B'. And by this construction, M is self-corresponding, so that MNAB is projective with MNA'B'. If in the above construction we have M equal N, we obtain a projectivity with the single double point M equal N. Definition: a projectivity on a one-dimensional primitive form with a single double element is called parabolic. If the double element is M, and AA', BB' are any two homologous pairs, the projectivity is completely determined and is conveniently represented by MMAB is projective with MMA'B'. Corollary: a necessary and sufficient condition for a parabolic projectivity MMAB projective with MMA'B' is Q of MAB, MB'A'. Assumptions A, E, and P. Theorem 24. If we have Q of ABC, A'B', C', we have also Q of A'B', C', ABC. Proof: by the theorem above, Q of ABC, A'B', C' implies AA', projective with AA', C', which is the inverse of A'A, B', C' projective with A'A, CB, which by the theorem above implies Q of A'B', C', ABC. The notation Q of ABC, A'B', C' implies that A, B, C are the traces of a point triple of sides of the quadrangle determining the quadrangular set. The theorem just proved states the existence of another quadrangle for which A', B', C' are a point triple, and consequently A, B, C are a triangle triple. This theorem therefore establishes the existence of oppositely placed quadrangles, as stated in section 19, page 50. This result can also be propounded as follows. Theorem 25. If two quadrangles P1, P2, P3, P4, and Q1, Q2, Q3, Q4 are so related, P1 to Q1, P2 to Q2, etc., that 5 of the sides, Pi, Pj, I and j equal to 1, 2, 3, 4, with I not equal to j, meet the 5 sides of the second, which are opposite to QI/QJ in the points of a line L. The remaining sides of the 2 quadrangles meet on L. Assumptions A, E, and P. Proof: the sides of the first quadrangle meet L in a quadrangular set Q of P12, P13, P14, comma, P34, P24, P23. Hence, Q of P34, P24, P23, comma, P12, P13, P14. But by hypothesis, 5 of the sides of the second quadrangle pass through these points as follows: Q1, Q2 through P34, Q1, Q3 through P24, Q1, Q4 through P23, Q3, Q4 through P12, Q4, Q2 through P13, Q3, Q2 through P14. As 5 of these conditions are satisfied, by Theorem 3, Chapter 2, they must all be satisfied. Exercises: 1. Given one double point of a projectivity on a line and 2 pairs of homologous points, construct the other double point. 2. If A, B, C are 3 non-concurrent lines and A', B', C' are 3 collinear points, give a construction for a triangle whose vertices A, B, C are respectively on the given lines, whose sides BC, CA, AB pass respectively through the given points. What happens when the 3 lines A, B, C are concurrent? Dualize.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.